Hello everyone. My name is Bruno Antunes from Wavecom, and I'm here to introduce you to the second part of the webinar series. This is a joint effort from the Big HPC project and UT Austin Portugal. And in this series, we will focus on the evolution to the new generation of big data and HPC applications. I wish to thank you all for participating in this session. In this webinar, we will welcome Samuel Bernardo from LEAP, who will be talking about linking GitOPS towards fast innovation over Big HPC. Samuel Bernardo is a software engineer at LEAP in Portugal. He graduated from Lisbon University with a degree in computer science and engineering, and is currently finishing his master's degree thesis. He's currently working on the Big HPC and software quality as a service platforms development, as well as in other national and European projects. He's also an open source contributor for many years, supporting the community and promoting free software. As I mentioned, my name is Bruno Antunes, and I'll be the moderator of this session. I'm currently a researcher and also research manager at Wavecom. I graduated in electrical and computer engineering from the University of Coimbra, and prior to the current functions, I also worked as external consultant at Wavecom for the development and production of the Wavec's multi-radio platform. Since January 2016, I assumed tasks on RD and RD management at Wavecom in several national and European funded projects, with one of them being this one, Big HPC, which I'm currently coordinating. Interact with us, use the chat to ask all your questions, to speak to us, and to report any technical issues. I would like to inform you that you can interact during the presentation. To do so, you can use the chat during the presentation. There are no discussion moments, but at the end of the webinar, we'll provide some minutes to discuss all these questions and interact with you. I'll be monitoring the chat activity regularly, ensuring that all questions are dealt with by the speakers at the right time. Please keep your microphone muted. This session will be recorded. And if you want to share questions live, please click raise hand and we'll give the mic to you so you can do your question. And now we can move to the presentation, and I will kindly ask Samuel to share his screen in order to kick things off. Samuel, the stage is yours.
Thank you, Bruno, for your brief presentation. Let me just start sharing here my screen. So thank you all to be here for this session. Can you see my screen?
Samuel, at least for me, I can't see it. Does
you can see it?
Okay. Oh, yes.
You can now see my screen?
Error. Yes.
Okay,
yes.
thank
you.
you.
Go ahead, Samuel. Go ahead, Samuel.
Thank you, Bruno.
Sorry for that.
Again, thank you to be here for this session. Here, in this session, I will talk about GitOPS and how it brings together developers with the operators and system administrators for the task of deploying applications and services in real infrastructures. So, summarizing my presentation, I will talk about the overview of Big HPC development challenges, then how GitOPS can help on those challenges, and also get GitOPS in practice. Afterwards, talk a bit on some more details around GitOPS applied to Big HPC project, and then in the end, our next steps. So moving on to the Big HPC platform. This is the current architecture for the Big HPC platform. So we have three main components: the virtualization manager, the storage manager, and the monitor backend. In the end, we need to have this platform delivered to the users and also to the system administrators, so everyone just interacts with this solution. Moving to the part of users and interfaces. This is another kind of challenge that impose. There are some kind of solutions like the Jupyter Hub that provides a platform where it's possible for the users to manage their code and their execution jobs, and also for the administrators to manage also the work from the users. Not only that part of the management exists on Jupyter Hub, but also the code management. So you can, for example, with this kind of solutions, have an editor with all the environments predisposed, like with, in this example, a Python 3 with GPU, for example, and you can access all of these from your browser. But this is not only about Python or about Jupyter notebooks. You can also have another kind of interfaces that can leverage additional softwares, services, and also additional access and view of the system status. For example, another kind of example for this is using the on-demand web interface that allows the interaction between the users and the infrastructures. So all of this to say, what is the complexity that we are dealing with when we manage this kind of platforms? So there are many components that needs to be integrated, and we want that all of that components be deployed as often as possible. We also want to just recover quickly from an error if one of that components are not working as expected. We also want to put all teams together in the same direction to manage this platform, and of course share the knowledge between all the partners, and also produce good documentation for the users to, and not only users, but also those that want to reproduce our work in their infrastructures. And another very important point is about the software quality. So you also want to disposal good software and good solutions for those that wants to contribute or to use it in their environments. So looking how GitOPS can help us with this, and I will start with a brief presentation. So the idea here is that GitOPS is a relatively recent concept. It was incepted by Weaveworks, and it comprehends the idea of connecting the developer workspace and the infrastructure definition all inside the same definition of a Git repository. So everything in the end is just translated into code. So this means that besides the normal software repositories, you will have also the infrastructure repositories. And that infrastructure repositories just translate the deployment, for example, or the configuration required to deploy an infrastructure. Of course, in this kind of environments, the idea is that there is no requirement for the developer to access the infrastructure. And also, those that manage these kind of infrastructures, they can just provide a way for the users to access that kind of infrastructure without more difficult credential management. So looking to the overview on GitOPS, so this is just like a simple example. I will enter more detail on next slides, but the main idea that I just explained is this. So you have the code repositories on some popular platform like GitHub, GitLab, or any other one, anyone else. Then you have the CI/CD pipeline, so the continuous integration and the continuous delivery code that processes the tests of the software and do the deployments. And then there is some kind of operator that manages and controls the deployment of the infrastructure that can be on any kind of infrastructure that you have. So why we should bring here GitOPS. So normally GitOPS sets or use same procedure to deploy applications without the burden of switching between required tools. It also brings a lighter learning curve because it is a kind of common language for developers that will enter and start using the infrastructure. It also provides for the operators or system administrator side a simple way to recover from failures, for example, and also for the developers when they just do a release and it doesn't work, it is also possible to easily go back with the git revert. The thing I mentioned before about the credentials management, and also and I will show in the next slide, but that the developers don't need direct access to the deployment endpoints. Also the complete description of all work that is being done. This is very important. And also the point I mentioned before about sharing knowledge with good commit messages and have all the work in a way that you can reproduce it and also produce good examples for others to use it. So this is the idea that is kind of abstracted here with the GitOPS operator, so that the burden of credentials management from the developer side to access the infrastructures are just abstracted by this GitOPS operator that simplifies the access to the infrastructure. So code is ready, deployments are checked, and then they are automatically deployed on the existing infrastructures. This, of course, like is mentioned here, is like a kind of firewall that protects the real infrastructure from the code or the environments where the code are being checked and prepared. But this is not only the main point. There is also some strategies associated with this kind of GitOps, because GitOps is about the deployment. Overall, the main point is about deployment. So there are two main deployment strategies. The push-based one, that is about that we have kind of these kind of implementations with GitLab CI/CD, Jenkins, Circle CI, or Travis CI. The main idea here is that every time that there is a code update on the Git platform, it will just update the environment repository. That then triggers the event that provides the deployment of the pipeline. The only thing that this kind of deployment strategy misses is that it just follows the state of the repository code, but it misses the state of the deployment or the state of how the services are deployed in the infrastructure. And this also reflects also in the image registry. So there are images being built, but those images could not be in the same state as expected. So to solve this kind of issues, there is another deployment strategy that is the pool-based. And for solve these kind of issues is introduced the operator. So what gives here the operator? So the operator gives the idea to have some definition that allows to check the state of the deployment and also the images in the infrastructure, and assures that everything is in the same state on the code side as also on the infrastructure side. And this is not only the only issue that we have to manage. There is also more complex deployments like this with the Big Hpc platform, where there are multiple repositories of code and also multiple environments. And for this, this is not a problem for this GitOps approach, since, as you can see on this diagram, all updates can converge to the environment repository. And the solution for the multiple environments means create multiple branches for the environment repository. And from there, you can deploy all required environments. So about the Big Hpc platform. So what we are doing here? So we just adopt the GitLab platform that allows us to implement the continuous deployment for applying the software quality best practices. It also provides a way to deliver well-documented history of system changes, promote shared knowledge and get teams together, and also easy reproduce the thought process of changing infrastructure and get the examples to set up new systems. Not only about the management of code and deployments, there is also the definition of the environments and the hardware profiles and application requirements that is related to our test beds of the details about the environment, and also gather all possible applications that needs to run on this kind of infrastructure, and prepare, of course, the pilot to test the platform as a final delivery. So looking to the current implementation workflow, the idea is simple. As a first step, so you have here the developer environment, and then you would start to use a more simple approach that that is almost similar to the common environment of the developer, and that is reproduces on the GitLab platform. And then there is the CI/CD from GitLab that allows to connect the test beds with the code, as applying the strategies for GitOPS. So the first part, and this is an important part, is about the project management. So about teams collaboration, issues management, and all that kind of stuff. Also, GitLab is very useful on that concern, because it provides the concept of groups and the concept of projects, where groups just collect all projects, and then you can review all issues and all activity on the project on the same board. So like this, like I'm showing you on this slide. So you can also view from a group or a subgroup all the activity that is being processed on a current work. Looking to an example of our pipeline. So this is a simple example where we start to build the required images. Then we run and test the software on the development test bed, also run the required tests on the preview test bed, and then we deploy to the production. So this is a kind of application of concepts from the GitLab pipelines into this representation, where build, development, preview and production are stages, and behind those are the jobs. So what is a job? So a job is something that is very simple, and this is the only step developers need to do. And this is a very important point for us to adopt GitLab, is that it is very easy to start working with pipelines. So you only need to define the stages, and you can do it directly from GitLab, as you can see here. And you only need to define the stages, and then create the jobs that you associate with each stage. On the definition of each job, you only need to place the command lines that you need to run with the required environment on each job. So such as simple as that. Then about the integration of this configuration file or this pipeline. Well, first you can start with a template that already provides you that kind of structure I mentioned you before. and you just start to associate that pipeline to your repository. When you just do this kind of association, we'll start seeing the pipelines running, and in the end, you will see the result, like showing in this slide when it passed. Also, and not only, you can see more details on the pipeline if you click on the pipeline, and you see all the state, like I showed on the first slide, with all the jobs and the states. And we can also see all the details of the jobs, because this just spawned all these jobs you see there. And then you can see the list of jobs, and you can enter on the job and see the details of the job. And here you are seeing what is the most valuable thing that allows the developer not to look or to access the infrastructure, that you can see actually what have happened on the infrastructure. So you can see the comments that run there, the logs, what have been shown to the std out and the std error. So you can just do all the kind of debugging without the requirement to go to the infrastructure itself. Then there is some mysterious point here, right? So we miss, how can we access that kind of infrastructure, and how can we associate those different environments? For that, GitLab provides the GitLab runners. So GitLab runners implements a set of executors. Some examples of executors can be Docker or Kubernetes, and each GitLab runner have its own access policies. And it can also be limited, the access placing tags for each runner. This to implement the GitOPS approach from GitLab, as I mentioned previously, here on GitLab, we are limited to the push-based strategy that is implemented by GitLab agent. And the idea is that is shown on this diagram on the left, that there is an agent that is running on in the Kubernetes cluster that opens bidirectional streaming with the GitLab agent server, and then it just provides a way to check and access the infrastructure without exposing to the live internet, let's say, and keep here completely isolated the infrastructure from the GitLab platform. Well, but here in more detail, you can see what is going on. So you actually have the main repository for your applications. Then you have the manifest repository where the changes are updated, just like I mentioned before on the push strategy deployment. And then the Kubernetes agent will regularly check for those changes. But this is not the only part that we need. We also need to deploy the Kubernetes agent, and that is also that configuration is also grabbed from GitLab itself and is also updated as needed. So you can also have in Kubernetes side multiple agents for this concern. But well, this doesn't solve the problems of the infrastructure state I mentioned before. And of course, this is a limitation from GitLab. And for that, there are another kind of solutions. For example, we can go for the Argo CD that implements the GitOPS pull strategy. And what is new here is that you have the operator definition, where from the Kubernetes side, you can run or you can have the confirmation of the state of the deployment and check it along the state of the code repository. And this also have the integration with GitLab and supports almost most popular configuration management and templating tools for Kubernetes. Another thing that is very useful is that it provides a web interface that allows to see the state of a deployment. So you can see actually what is happening during the deployment and also during production. This is a kind of big improvement where you can always be in update in the state of the code, and also, and not only, the infrastructure. So just summarizing here all the ideas in place. So we have the GitLab CD configuration that needs to be created for the required pipelines. Then you have to create the GitLab project and associated with the deployment code, and submit the code for the defined test beds. We will also need to connect GitLab project with the GitLab runner instance, like I explained before, providing, and this allows us to have the reports and all the information about the job execution. We also need to create the images to pack the required code that are then uploaded to the image repository. And all of these also provides the required infrastructure and definitions for us to produce the experimental validation and checking the automated results over the test beds. Afterwards, we can deploy the release to the production infrastructure, and that is it. We can present the pilot for further validation. So what is the next steps? So next steps is kind of more concerned with extending these concepts. So from the GitOPS side, we want to dynamically add resources from HPC sites. I didn't mention during this presentation, but there are another kind of solutions like Jenkins that also allows to manage infrastructure. And there are many kind of implementations that allows for dynamically loading of those resources. For example, here to use the Jenkins Swarm plugin, it allows for a node, for example, to be placed on or available for the platform, and anytime it is available, you can just link with it. For example, if you use some kind of workload manager where you submit jobs, you can, for example, launch a job, and it will be a worker available for Jenkins where you can later submit jobs for there. So there is this kind of behavior that is also capable to be produced here. And all of these components can be coupled in the same concept of GitOPS. Also improve implementation, just I mentioned in the previous slide, extending with other solutions like Argo CD. Also bring here, and this is very important, the good practices of team collaboration, because it's very important to create good commits, to produce the issues, to register all information, and to keep the documentation along the code development. Fortunately, GitLab provides all of these tools that we can just keep along in the same platform where we manage the code. And also another very important thing that is about to test the deployment. So just do some essays to see how we can recover from errors, and see in practice the advantage of this using Git. Another very important point is about the pilot. So we want to test the platform components with real use cases, and these are very important for us here, and also identify application performance issues. All of these can be easily adopted from the procedures I explained previously. And that's it. I hope you enjoyed this presentation. If you have any questions, I will be glad to answer them.
Okay, thank you so much for your presentation. I was just checking the chat room to see if we have any questions, but I think at the moment we still don't have any. Nevertheless, there was one thing that left me curious about GitOps. Considering this scenario, the scenario of HPC centers, where sometimes the user of Docker containers may be restricted, does the image repository is only about the Docker images, or we can use other technologies?
Yes, you can use any other kind of technologies, because, and this is a very important question. Thank you for that, Bruno. Because here we also have to deal with any kind of deployment solution. For example, just mention some kind of approaches. You can use Terraform or Ansible to deploy and to the deployment. And for that, you can have any other kind of images. For example, virtual machines, okay? The traditional virtual machines or based on full virtualization. So all kind of the concept there of image repository includes all of that possible solutions.
Okay. Okay. Thanks. Yes, because usually in this kind of scenarios we are used to use Singularity, and there are other virtualization and container technologies that can and should be used. I think there are still no questions. I don't know if anyone has raised their hand to ask directly, but it appears not. So, but I think I have another doubt regarding the infrastructure configuration. Is Kubernetes the only option to implement it, or can we use other orchestrators, or are we limited to Kubernetes?
Yes, that is a very good question, because there, for example, Argus CD, as I show you,
yes,
is tailored directly for Kubernetes. But actually, GitOps concept is not only for Kubernetes; it's for any kind of implementation. The point there is about the pattern and the strategy that we can apply to it. For example, now in Big HPC, we are using GitLab, and we can not only use Kubernetes, but also, for example, real machines or virtual machines, and also Singularity, just like you mentioned. So we are not coupled only to Kubernetes.
Mm-hmm. Okay, thank you. I think we still don't have any questions. I was reminding one slide that you had. You were talking about the pull strategy on GitOps, right? And where you introduced the concept of operator that will be aware of the system state, right? It was an advanced on the GitOps strategy. Does it mean that we have already service monitoring, or we still have to implement some monitoring on top of this strategy, this GitOps pull strategy?
Yes, it is a very, very important point, because actually it is some kind of monitoring that we have when we are using, for example, Argus CD, that keeps the state of the deployment. But that is not monitoring itself. Okay, it can be enriched with monitoring. It can be better and automated better with the monitored infrastructure, but there is always the requirement to have the monitoring for the infrastructure and for the services itself.
Mm-hmm. And now a more particular question regarding Big HPC. For those who aren't aware, this project has teams separated throughout Portugal and also in the United States. What do you think it's the importance of using a strategy like this, Git operations, when the teams are so separated, even physically separated? We haven't met in person since the beginning of the project. Because well, we all know why the reason COVID hit the world as a pandemic. And how do you think, what is the importance of using this kind of new technologies and techniques in this kind of collaborative projects where the developers are separated and working even in different time zones, for example?
Yes, yes. It is very important, at least to keep all together on track, and also to share the knowledge on the same platform where we can follow what each other are doing, and also with different time zones. That is a very important point, because, for example, we could start working now, and in the end of the day, the others will start the work.
Exactly.
So we can easily look to the activity. We can check what someone did on, for example, during when I was asleep, right? And then someone can bring here and start working with this kind of solutions. So it is also very useful for management. So I can also do some kind of Scrum approaches where we can just manage all the activity, and we see what is happening, and I can create issues for the other team starts from the other in the other day, or when they start their working day, and this is kind of approaches that keeps everything running. And also another very important thing that is about the reliability, so the time that the service will be available, because anytime there is some change that produces an error, the other team, so I don't need to wake up during the night to solve a problem, because everything will be there, will be correctly explained, and someone in the other day can just see what happened, and everything is there very detailed, and it's possible to correct that issues.
Yeah, yeah, I think in this scenario where we are working, where you have this case that, as you're saying, one developer can have an issue, and it will be reported, and the one that is responsible for solving it may be asleep, and can work on it on the other day without having to contact directly the other developer to ask for more details. We have here a question. I don't know if it's from João Paulo. I don't know if you want to ask it directly or if you want me to read it.
Sure, I can try. Can you hear me?
Yes, sure.
Thank you.
Hi, Samuel. Thank you for the presentation. So my question is the following: given all the experience that you are gaining from using GitOPS and doing this for a project with different partners in different countries and all doing development and research at the same time, what would be the key lessons learned that you learned so far and that you believe that would be important for other similar projects with different partners and lots of people contributing to the same goal?
Yes, thank you for that question. It is very important. So the first part is about trying to change procedures. So every day people start working on their code and are very close over their environment, on their development environment, and also misses sometimes the communication, let's say, channels. Okay, so one important thing this kind of approach brings here is opening these channels. So the communication channels to open the developer work to others, and this opening to others is very important because it brings also additional help sometimes that we are not thinking of it, and we can also have that feedback live, right? So it is very powerful in terms of creating teams. Okay, so to build teams, it is very important, and also to share knowledge, just like I mentioned. And thank you for that question, João Paulo. It is very important. And also the other part is about to start working with this kind of approach. So provide a way that could be so simple that anyone could start working with it without spending much time. And then they actually realize that when they start working with these solutions, they see that they spend lesser time because all the burden for the tests and that kind of things are already in place and you don't care about it. You can be more focused on code. You can be more focused on your work, and all that other kind of details. You can be we can just bypass them because we have the support from all the others. Okay, and this is very important.
Thank you.
Okay, thank you, Samuel. I don't think we have more questions in the chat. Please, if you have any question, raise your hand or use the chat. Give us your doubts before we close the session. I have one more question. It's like a teaser, and probably some participants are thinking, well, but my project is small, and this GitOPS appears as a very complex infrastructure. For those who are willing to at least try GitOPS, and please also elaborate in if you think the dimension of the team is very important, what would you advise as a first step? Is it easy to start with GitOPS? It's recommended only for big teams with a lot of developers. What can you share about it?
Well, actually, it is helpful for everyone, because what we are talking here is about to provide good releases and good deployments. And that deployments, even in small projects, are not only tailored to the development side, it is also for the user side. So if the users see something that is more clear in terms of the examples that are placed on the Git, and if you have also a way to get easier the feedback from the users, and that the users can reach you more easily. Of course, all of these are very important details that should bring these kind of definitions that GitOPS brings here to the any kind of project. And the other thing that is very important here is about using Git. So many times people are developing small applications that are outside a control version system, and that you are also missing all the information that you do during the development work. So anytime you are developing, you pass over many issues or challenges, and when you use a Git flow, you are just keeping that history and all the work you did, placing commits with good descriptions, and in the end you have all your history of your development. And so this, even for small projects, can be very valuable, also to attract other contributors. And so as you can see, for example, in examples like GitHub, actually there is a popularity rank, and these kind of things are promoted. So of course GitOPS can be applied to any kind of project.
Okay, thank you, Samuel. So I think we haven't got any other questions. I don't know if there is something that you still want to share with us regarding GitOPS. If that's not the case, yes, Samuel.
Well, from my side, just be free to contact us or me directly if you want to start working with GitOPS, and I will be very glad to help you with that.
Yeah, thank you. Yes, and we as we say, we are using it on Big HPC, so there's a clear sign of trust on this kind of platform. So I think from my side, I think we can close the session. I think you are seeing my screen, right? Thank you for joining us. See you on the next webinar. Please stay tuned for the next webinar. The subject This time will be user-level software-defined storage data planes. This next section will take place on May the 5th. And Ricardo Macedo from INESC will be the presenter. So thank you all for joining us and hope to see you again on the next webinar.